Hey, this is on from Padlock Technologies again with another video. Now, if you follow me on LinkedIn or if you subscribe to this channel, you would know that I was working on a mock of an SDA fabric using Catalyst 9K. So I'm going to do MP-BGP EVPN in Catalyst 9K. Now, I'm not going to use Lisp for this. This is strictly EVPN. But I took it another step forward and I simulated, or further, I simulated what a fabric with a DC fabric would look like and how those two connect together. Now, before we get in the lab, if you get any value from this video, please do not forget to share, comment, like, and subscribe, and definitely share this video in particular to your network. Growing my channel, I get subscribers every day, I get questions every day. Really loving this. We've grown this community from a small little channel to now what it is now. Doesn't cost you anything but a little click of a button, and I really appreciate it. And before we get to the lab, I want to shout out EVNG. EVNG is by far, in my opinion, the best network simulator on the planet. CML, great. EVNG, phenomenal. I know there's GNS3 for my GNS3 users. I used to use that as well. But I just want to shout out to EVNG, especially the professional edition. These guys have been working really hard in developing that platform. And to be honest with you, without that platform, it would be very hard to actually, get the practice that you need to actually do some of these things in the real world. So appreciate it. Now let's get to the lab. So now here's the infamous lab. So it started out, and again, if you see me, if you got me on LinkedIn or if you subscribe to the channel, you would know that you noticed that I originally started out with just this catalyst fabric here, right up in this area here. So, ASN 65003 all the way down to 65001. This is the campus side. Now I also have an internet block, which is ASN 65004. We have shared services up here where I'm just simulating shared services technically. This is not really AD, this is not really ICE or anything like that. We're just simulating this because this will be a campus fabric. If we were doing wireless, you have the OTT, which is over the top. If I had wireless, and people would pop out of this WLC out to this end here. And then we have our DC fabric, which is our WAN connectivity over here, which is a normal Nexus MP-BGP EVPN fabric. Here, this is a Catalyst from the Fusion routers down. This is a Catalyst 9K MP-BGP EVPN fabric. Now the underlay in the campus side is ISIS, and the underlay for the data center side is OSPF. So I'll mix the two together this time. I am running multicast in both. So we're doing multicast to do the, we're not doing ingress replication because just run multicast in your fabrics. It's a lot easier and a lot more efficient. But if you do ingress replication, that means you're just creating a copy of the packet at the head end multiple times, which is not that efficient. Then we have our fusion routers here. This connects everything from an L3 standpoint. Basically, this is a fusion router or two fusion routers and a VPC, and it's all layer 3 pretty much here. Now, there is some layer 2 because I do have a VLAN 10 that actually pairs to the Fortinet firewall, so I'm using those from a BGP standpoint. But as you can see, this entire environment is BGP, right? To do the internet networking and stuff like that. The underlays of each fabric obviously is going to be an IGP there, but from one fabric to the next is BGP, to both fabrics to the firewalls BGP, from all fabrics to shared services is BGP. Now you're probably going to ask, why did I just do BGP everywhere? Well, it's very simple. I did not want to have to worry about redistribution, right? I didn't want to have to worry about, okay, I'm using OSPF. Now I got to redistribute OSPF into BGP and all that other nonsense, mutual redistribution. With BGP, all I have to do is make sure the ASNs, at least when I'm going out the fabric, is different, and then it'll just propagate it, and I can use, filtering and other techniques to get there. So before we actually get into the different configurations, I'm not going to be like other YouTubers and just show you configurations and you're probably wondering like, did that actually work? I'm going to actually show you it works, and then we're going to dig into the configurations first. So we're going to this VPC here. Let's open that up. And then we're going to open up another VPC over here because this is going to be simulating data center to campus connectivity here. So before we get into that, let's go to show IP. So now you see this is 192.168.1.1. And if I do show IP on this side, we got 10.100.1.1. So to verify connectivity, we're just going to do a simple ping test. And there you go. I am leaving the fabric, going into the DC fabric. I'm leaving the campus fabric, going to the DC fabric, and I got connectivity. Now, there will be some timeouts because obviously I'm pegging the mess out of my lab right now. And I'm doing clustering, by the way, for anybody that asks. I have two big servers that are in one Eve cluster. That's how I'm able to make these big super labs and stuff like that. Probably going to buy another big Q servers and add it to the cluster to do even more ridiculous labs. But as you can see, we have connectivity there. Now, let's ping the internet. So this is going to go out of the FortiGate. And as you can see, I'm going out of the fabric and I'm going to the internet. Let's go from the data center fabric. So same thing, data center fabric. Well, we already saw it ping. I was able to ping 192.168.1.1. So there's no point of doing that test again. So I will ping the internet so you can see I have internet connectivity through the FortiGate as well. Okay, so that shows you that it works. Now I'm also going to show you from the Fortinet side, which is we're looking here. We'll just slap up in there into the CLI, and just to make sure you know it is BGP. So we're going to go get router info, routing table BGP, and as you can see, the Fusion router is propagating all these routes to the FortiGate. All right. So this is how the FortiGate knows how to get back to everything because I'm propagating it via BGP. And then my BGP configurations should be somewhere down here. Here's my BGP configurations. Now this 99.1 is VLAN 10 on Fusion Router 1. 99.2 is the VLAN 10 on Fusion Router 2. Okay, so 1 is Fusion Router 1, 2 is Fusion Router 2. And I'm doing default information originate. So I have a static route on the FortiGate that I'm doing default information originate. So it's going to propagate that quad 0 down to the Fusion router. And then the Fusion router is going to propagate that to both fabrics, including shared services, which is up here as well. So if I went to this fake AD DNS CA, we're just going to show IP routes. And then if I were to try to ping it from here, I can get to the internet from shared services as well. So now we have, you don't have to worry about wondering, hey, he just showed us all this and it's not technically working. I definitely got this up and running. Oh, I do actually want to show you as well that we have interfabric stuff working. So we go to 192.168.1.2 interfabric. So that's over here on VN2. This is actually VPC 13. So you actually see my inside the fabric stuff working. And then we'll just validate this as well on server. On the fake server 1, we're going to go 1.2, and that is actually VPC 38, which is this one right here. So as we can see, interfabric is working as well as going outside the fabric. So now let's get into the differences between doing MP-BGP EVPN on a Catalyst network versus a Nexus network. They are totally different. And I'm going to tell you right now, Nexus kind of hides a lot of stuff behind the scenes that you actually have to manually do on the 9Ks. So the next question that you're probably going to ask is, why do I have different ASNs for the spines here? Now, this is something that I just, decided to try on this build here. Normally, you would see in normal fabrics, you would see IBGP, and then you just have to worry about route reflectors and all that good stuff that you have to configure. The reason why I did it this way is because I want to treat the spines technically as just route servers. So I don't have to really worry about doing route reflector clients and all that good stuff. And it was just a different way of doing it. And I wanted to experiment and see how it works. Now, when you do this though, there is some things that you need to do, right? First and foremost, you need to disable a certain uh, default feature in BGP. So let's go in here and I'm going to show you what I'm talking about. There we go. So we look, I don't know why I just did that because I clearly just hit the wrong key. So I'm just going to spine 2 right now. So this always makes you put the password in. Hopefully I didn't fat finger that. And I did. Okay. So if we look at the router BGP configurations, I'll wait till this comes up. So very simple. Here's what I did. So if you studying for your CCNP or anything like that, you should know these commands here. So what I did was do a BGP listen range command. This is sort of like the neighbor group command on the Nexus, right? Sort of. Um, technically, I'm gonna take that back. It sort of is not like the neighbor group because the neighbor group is technically like a template. But here, what this basically does is it's going to listen for any neighborships that are coming from this subnet, and it's going to add it to this peer group, okay, called fabric peers. Now, the fabric peer stuff is you got to actually name the fabric peer. Then you just do your typical, okay, that fabric peer is remote AS, 65001. You have to do eBGP multi-hop because iBGP, by default, the TTL is 255, right? By default. eBGP, it's 1, so decrement the value of 1. Now, I could have used TTL security here and say, TTL security 2 or 3 or whatever. But I just did eBGP multi-hop because a lot of people know that way versus TTL security. And that's basically saying because I'm going with the loopback, because it decrements by 1, the loopback would technically be 2. So the neighborship wouldn't come up if I didn't have this command, because once I decrement the value 1 for my next hop, which is the link between us, well, then the packet dies at that point. So you have to do a multi-hop of something greater than 1. So I just did 255, right? And then I did the update loopback source for my loopback. Now, what was different? The default feature you have to turn off is this right here. So by default, there is a rule in BGP that says if I do not own the VRF or I do not have any VRFs, I'm not going to propagate any information. Basically, any routes that come into me, not really going to propagate that because I don't have the VRF technically configured on my router. So you have to turn this off by using no BGP default route target filter. So for my service provider people, this is like doing inter AS MPLS L3 VPNs option B, right? So option B, you have to actually do this here on your ASBR so that it can actually send those routes to the other ASN. So you have to do this here. Now, the other thing you need to do is you activate the neighbor for L2 EVPN. And then you have to send the community values of both. And then this is another critical thing you have to do is you have to send this route map of next hop unchanged. So if we look at the route map here, now our route map here says set next hop unchained. Now you need to do this only when you're doing IB or eBGP for a fabric because normal eBGP rules is if I send you a route from me, I change the next hop to me. So what ends up happening is you cannot create the VXLAN tunnels because the next hop would be the spine and not the actual other VTEP, so to speak. So in this design, if I did not have the next hop unchanged, FE1 would see a next hop of spine 1, and you're not going to do the tunnel for that, right? Because you're not going to have the NVE interface on here. So you need to make sure that when I receive the routes, the next hop isn't changed, and it will show like if routes come from FE2 it will show, hey, the routes are going to FE2, and that's where you're going to build the VXLAN tunnel to. All right. Without this, the VXLAN tunnel will never form because it's coming from something that doesn't have an NVE interface. So that's really the difference when you're using eBGP in your fabric. Okay. Now, from the fabric edge standpoint, if you want to call it that, well, technically that's what we would call it. The configurations on the Nexus is very, very different. And when I say that, the Nexus hides a lot of things from you that you have to manually do here, I'm going to explain that. So when you do it on the Nexus, and I want to show you on the Nexus as well, when you go to configure a VLAN to VNI mapping, pretty simple on the Nexus. You just do VLAN, whatever the VLAN is, VN segment, whatever the VNI is. That is not how you do it on Catalyst, okay? So on Catalyst, what you have to do, and this is why I said if you're used to doing EVPN on the service provider side, you're pretty much going to know a lot more about how to do this on Cat 9Ks, because that's what they pretty much stole the configurations and just said, okay, this, well, not stole, but they took the configuration from the service provider and then pretty much said, okay, this is how we're going to implement it on Catalyst. So first thing you will need to do is obviously have the VLANs, right? So if you go to show run VLAN, obviously you need to have your VLAN set up. So these are, here's my VLAN configuration, some of the stuff. Then we have our VLAN 10 through 30. So we go show VLAN brief, and I'm gonna explain what all the other ones are. So we go to show VLAN brief. Here's the 3 VLANs that I created. Okay. So now let's talk about what you just saw up here. And we're going to go through this. So the first thing you need to do is create your L2 EVPN instance. Now, again, a service provider, if you're used to doing that on the service provider side, you already know what this is. So what you're going to do is go L2 EVPN instance, the number, VLAN base, and then the key here is you're going to do encapsulation VXLAN. And you're going to do this for every one of the VLANs you want to create. So I did 20 and 30, okay? But you're not done. The next thing you need to do is now you need to map that VLAN to a VNI. Now, remember I told you on the Nexus, it's just VLAN and then VN segment, whatever the VNI is. Well, on Nexus 9, Catalyst 9Ks, that is not the case. You have to go VLAN configuration, the VLAN number, then you got to go member EVPN instance, VNI, whatever the VNI is. So you have to take this VNI is this L2 EVPN instance that you just created up here, and then you have to map it down here in your VLAN configuration. So VLAN 10 basically is going to be a member of this L2 EVPN instance, and the VNI number is going to be whatever you want to call it from that point. So that's technically the layer 2 stuff, right? This is the layer 2 VNI that you're going to create. The layer 3 VNI is going to look like this. So I have a VLANs 3000 and 302, 3000 to 3002. And what you're going to do is do member the same VLAN configuration. So VLAN configuration 3000, but the difference is you're going to do member VNI, whatever the number. All right. So you're not mapping it technically to a layer 2 or an EVPN instance. This is your basically you're going to be your layer 3 VNI here. All right. So that's just the mapping part. Again, on the Nexus, when I show you, you're going to be like, that's totally different. It's a lot easier on the Nexus. I wish they would have just took what the Nexus did and put it on here. Now, the next thing you got to do is everything's pretty much the same at that point. So you're going to look at your NVE. Let's look at your NVE interfaces. So actually, before we go to that, let's go to VLAN 10. All right, so you create your VLAN 10. I'll show you what this VRF is and what that looks like. Now, I attempted to do some DHCP relay stuff that I haven't got working yet, but the really thing that you really want to pay attention to is you put it under your corporate VRF, and then you give it a subnet. You have to give it this MAC address because this is going to be an Anycast gateway, so it has to have the same MAC to IP address. So when you do your ARP, it gets the same one. Don't worry about any of this DHCP relay stuff. Now, what it would look like without the DHCP relay stuff is this. So basically, that's what it looks like. All right. without the IP helper, because I started doing that and flat out I just stopped just because I wanted to get this video out here, and I didn't create the DHCP server. Now the next thing here is let's look at the VRF so I can explain what the VRFs look like, and then we'll get back to, I believe I had the configurations up here. We'll get back to the interface NVE1. So if we look at our VRFs, here's the VRFs. So if you got any knowledge in MPLS, you kind of know what this is. So we give it the route distinguisher to give it a unique route, all right, because your RD is going to be attached to every one of your routes. Then we're going to do our route import and export commands. Typical for MPLS stuff, MPLS guys, this is basically you're going to import it into the L2 EV. Well, this technically would be an MPLS, right? You're just going to import routes with this route target value and export routes with this route target value. So basically, on the other end, if I'm matching the same thing, we're going to exchange routes. If I'm not importing or exporting the same thing, then you're not going to see my routes. All right. Now the key with the VXLAN part is this configuration here. This stitching part is is a keyword used for VXLAN on 9Ks. Okay. Now in the Nexus, you can just do route target both auto and let the Nexus auto create all this stuff. On the Catalyst, there's really no auto. So I did this for the corporate, the guest, and the IoT. So I created 3 VNs, right, which are basically VRFs, technically. Even in SDA, that's what they are under the hood. They just called it virtual networks. Now, once we're there and we attach, I already showed you, showed you that. So the VRF now is under guest. So everybody in the fabric has the same mapping, same VNI, same VRFs, same SVIs, all that's the same. And then we have to go back to the NVE interface. So we got to go to NVEs. So this is your network virtual endpoint. Don't quote me on the actual NVE, what that is. Meaning, don't quote me on the exact name. I think it's network virtual endpoint, but don't quote me on that. So this is what's going to create the tunnel between the fabric edges. Okay. So as you can see, for each one, I created 3, one for each VRF, because you technically can't use the same look back for a different NVE. So when I show you NVE2, I don't know why I got that on there. You see it's a different loopback. It's loopback 1, and when I show NVE3, it's loopback 2. So they're never going to be the same. So basically what this is it's your virtual endpoint, which is going to do your VXLAN tunneling from data plane. From a data plane perspective, this is what it's going to use to actually do that, tunneling. So your NVE, I'm sourcing it for loopback 0. I'm using BGP as my host discovery. So once a host attaches to the fabric, it's going to send that through BGP through the EVPN table, and then everybody that's in this multicast group is going to get that, right? So here's my VNI to multicast group mapping, basically saying, hey, this VNI, which I showed you before in the VLAN configuration, this VNI is going to map to this group, which is 225.0.0.10. And then if I need to go outside or do some type of layer 3 stuff, I'm going to use my layer 3 VNI, which is technically VLAN 3000 for this, but the VNI that I have for VLAN 3000 is 33.0.0.0. And then you see the same the same configuration on each of the other NVEs. So that's basically the setup for everything here, right? Everything here at the bottom. So FE1, 2, and 3, right? So if once you got all this and the peerings are being set, what would technically happen is if I do show BGP L2 EVPN, you see my route table is all full. You see the type 2 route, so this is your MAC to IP MAC to IP binding right here. So that is in FE2. So that 192.168.1.2 here is the MAC address for it. You can tell because you see 48 there, so that's the MAC, and then you see 32 for the IP address. All right, and all this other stuff is technically these type 5 routes are routes coming in from the outside. All right, so this is what that would look like, and you see all these crazy ASNs on here. All right, but that fills in the actual table, or the L2 VPN EVPN table. If I was going to show IP route, VRF corporate, since that's VLAN 10, you would see I have a default route, and I'm going to show you how I got that in here. And then you see all those other routes coming in from the Fusion router. All right. Now you notice you don't see 192.168 2 dot something, because I'm not advertising that back down. I'm literally, this is your macro segmentation at this point, because the Fusion router is only sending the default table down, and we're not intermingling the other two VNs in the fabric. Okay. So once we're there, we go show MVE peers. Now this shows you the tunnels that you're going to create with peers you're going to create, or the peers you can create tunnels with. So here's my peers, and as you can see, I have 6 and 6, and I believe 6 and 7 is the border. So I got 6 here, and then 4. See, this is, so FE1 is 3, 4, and 5. So you see my pairings there. And then if I wanted to go now on Nexus switches, if you wanted to see a MAC address on another fabric edge, you would just do show MAC address VLAN, whatever, right? In Catalyst, it doesn't work like that. So you do show BGP, I think it's L2 VPN EVPN MAC IP, I believe. Don't quote me on this. Let's see what we got. So, or is it show L2 VPN? I could be wrong there. EVPN MAC IP. There we go. So there you go. So as you can see, and I'll just use 1.1. So 1.1 is local to me. All right. So it's going out of the G103 address, which is that one right there. All right. Now, if I wanted to get the .2 though, I'm going to create a tunnel to 4, which is FE2's loopback address. Same thing if I wanted to get to 3, I'm going to go to 5, which is FE3, which is over here's loopback address. Okay, so this is the tunneling. Now I do like this because it does give you the layer, the MAC to IP binding, but it also tells you, like, hey, if you want to get to this MAC, you need to go over. It tells you the tunneling mechanism. Now this command is, like I said, it's not as well as Nexus, because if I just do show MAC address table VLAN 10, you notice I don't see that tunneling that I have up here compared to Nexus. If I do that, and I'm going to show you, you'll see it in there. Now this is going on every one of these nodes up here, from the fabric edge nodes at the bottom to the border nodes at the top. So if we look at the border node here, let's log into this border node. So we log into the border node here from a BGP perspective. Now I did have to do this specifically. I did not create anything in the global routing table, but I had to do it on the borders, because when you do the Fusion router and you're doing the route leaking in between, if you do not have an IPv4 unicast and you try to, you do a default originate, or you try to do something internally, it will not work. So it won't do the route leaking from default table to the whatever VRFs you're going to. So you at least have to have IPv4 up. So if we look at unicast summary, as you can see, we have some data coming in here, some routes coming in here, but that's not really important, because I'm only using that to get the default route into the VRF tables. Now it's important in SDA because the infra VN is technically how you would get like APs to come up and stuff like that. You need the infrastructure, the underlay VN, stuff like that. So that's important in SDA. And this one, I didn't try to mimic that. So from a route perspective, So I just show BGP VRF corporate. Let me see, IPv4. Do I do IPv4? Can I do that? Corporate. Is unicast summary in here? Summary. Oh, wrong VRF. Let's go here. So here's the routes that are coming in from the Fusion router. That's coming in there. If I go guest, same thing on the guest side. You're probably wondering how am I getting those routes in there. I'm explaining it in a minute. And then IoT. So that's all coming in. Okay. And then if you look from a BGP perspective, if you look at the BGP stuff, and I'm only going to show you one Fusion router because it's the same on the other one. So if we look at the BGP stuff, everything is pretty much under my peerings are going to go from on the VRF side. So this is VRF Lite. I have some sub interfaces on the G001 interface. So there's a bunch of sub interfaces here on G101 and G102. And I'm using those BGP connections. And then the key here, at least on the Catalyst side, is you have to have this underneath every one of your, families here. Because without this command, it doesn't advertise it into the L2 VPN EVPN database. Doesn't even advertise it into the route table. Now, in the older versions of Nexus, you had to do this. But now Nexus actually does this for you automatically. So if we go down back to this VN here, and as you can see, I'm redistributing connected. That just means anything that's connected for a VLAN. But you can see here, advertise L2 EVPN, L2 VPN EVPN. If you don't do that, it will not advertise that route into the table and your table will be blank and nobody will know how to get anywhere. Okay, Nexus does this for you already. So once we got everything here, let's talk about the Fusion router and how I got those routes in there. So from a Fusion router perspective, I'm only going to show you one because, again, all the routers are pretty much the same. From the Fusion router perspective, everything is in GRT, except going down to the Catalyst network, the Catalyst fabric. So if we look at the route table here, actually, let's look at some VRFs, because I'm going to show you why we got stuff in there. So we go to section VRF first. Oh, I know what I did. Forgot to put sec. All right, so here's what you will see here. We have 3 VRFs that match the same VNIs, or not VNs coming from the corporate side. Now, what we did is this is how we're going to leak routes from the default table to each VRF. So what we're going to do is I have a route map that's all routes that basically is blank. So that means permit everything. If I technically wanted to do something with the guests and block out access to the data center, I would just do a prefix list, a route map that says deny the data center routes. And then I would do, import default map route with that route map in there. And then the guest network would not be able to see the data center routes. That's really it. But from here, since I, didn't want to make this too long, we're going to do import VRF default, which is the default routing table, map all routes. So basically anything that's in the default route table, just send it into this VRF. And then we're going to say anything that's in the VRF, export it to the route table, the GRT. And we did that for all 3 of these things, all of these. All right. And then when we get to our BGP configurations, you see a lot of this stuff. This is basically all our BGP configurations here, and I'm just going to focus on. All right, so here's our global routing table stuff. This is going to the border gateways in the DC, and it's going to the firewall. But this is how we're getting BGP to just mush everything together, so everybody can see how to get to everywhere. This is global routing table because the firewalls are in the GRT, and the border gateways interfaces pointing towards the fusion routers are technically on the global, on the gateway side or the border gateway side, they're technically VRF light, but there's no need to do VRF on the fusion because I want everything in the GRT. But from going down to the Catalyst network, we have our different VRFs here. And as you can see, here's where you see the default originate. So, and you see that I have to do default originate all the way down because it's in the routing table doesn't mean it advertises. So I did default originate, and that's how I got everything down. All right. Technically, I could have not did that, and it wouldn't have did anything. So because I didn't do it on the other two, I think that's just older config that I forgot to take out. But that's MP-BGP down. Right? And now we're leaking the routes in between the two. So now, we're leaking the routes between the global GRT or the GRT and the VRF. So anything that's in my GRT will automatically get sent down to the VRF, which will automatically go down to the border gateways, which will go all the way down to the fabric edge node, which is what I showed you. Now, if I do show, let's look at the global routing table because I want to show you something specific with that route leaking. What happens when you do it that way? So we go show IP route, and what you will see, let's expand this a little bit. I'm going to use 1.1 again, 192.168.1.1. Let me just find it. And what you will see is right there. You see where it says corporate? So that's basically saying to get to this IP address, which is a /32, you need to look into the corporate VRF to get there. And it's being advertised by, ASN 65001. So that's basically what the route leaking at the fusion router did. It told the global routing table what VRF to look at when you want to get to this specific route that's coming from the corporate VN. All right. And again, this is all your macro segmentation because I'm not doing anything with SGTs or anything like that. Now, before someone asks, from a security standpoint, you can make the fusion router whatever you want. Most of the time, I'm either going to see it as a Nexus switch, or it could be a firewall, and then you put everything in its respective zones, and then you can dictate the traffic between there if you really, really want to be secure. Because really, nothing's really stopping anything from talking to anything here, other than if I did something from a route map perspective and just completely remove the route so it didn't know where to go, right? But if it's sending down the default route, it can still technically get there. So you would have to create like ACLs or something that you would put on the ports, the inbound in the inbound direction. But if you're going to be doing that, you might as well just use a firewall for all that. So that is the Catalyst campus fabric going all the way up to the fusion. So let's look at what it looks like on the data center side. So the data center side, again, is a little bit easier because, they mask a lot of things. Now, I will show you, because I'm doing the same technique with the EBGP. There's one thing you need to do on the spines here that I want to draw your attention to. And I think I have some old commands in here, so I'll draw your attention to everything else. So the one thing you need to do is there is technically no BGP default route target filter command in Nexus. But what you really have to do is for the L2 VPN side, you still have to do the route map unchanged, which is basically set IP next hop unchanged. But you also have to do this retain route target all. This is the command that you would use when you want to do no BGP default route filter or no BGP default route target filter, right? You would technically use this command. If this command is not in there, it will not send those routes to your VTEPs. Now, we're going from fabric edge, because that's campus fabric terminology, to VTEPs, which is data center terminology, but they're technically the same thing. Now, I did some template stuff, but from a neighborship standpoint, you also have to do this disable peer check in the Nexus platform. You have to do that because when you're using eBGP, Obviously, the neighbor disable peer check AS, peer AS check. You want to disable that. They didn't really give a clear, like in the description, why you. And this is for eBGP only. They really didn't give a clear reason for this. They just said that you need to do this. All right. So I'm gonna do a little bit more research of why and see if I can get a clear explanation for you guys. Probably next, I'll probably put it in the notes or something like that. But everything else is pretty much the same thing. You got to send the community values, and you need to actually make sure the next hop is not changed to the spines when they go to the VTEPs. That's pretty much it from the spine standpoint. Now, from a VTEP standpoint, and I'm not going to show you all the VTEPs, I'm going to show you one because it's pretty much the same on everything. Let's go down to all of this. So now I am running multicast as well in this one as well. Now, obviously, you need to turn on the feature. So I didn't show you that on the spine, but I will show you here. So let's turn on the feature. All these features need to be turned on. So OSPF, BGP, PIM, interface, VLAN. So this is your SVI stuff. And then your VN segment, VLAN base. This is the stuff you're going to need to do VXLAN. And NV overlays, you need that. And then there's another command called NV overlay EVPN that you need to actually set. So when all these features are turned on, you're able to do this. The next thing you need to do is you're going to have to create the fabric MAC address. So this fabric MAC address is going to go on all your SVIs because like I said, just like in the Catalyst Center one, the MAC address to SVI has to be the same, right? So when you need to talk to your gateway, this is for workload mobility. So let's say I move it to another VTEP. When I do the ARP, the MAC address to IP address is going to be the same. If you change it, now you're going to have some problems there. So once you have that done, so now we're going to look at the VLAN. Hopefully it's that one. So let's look at the VLAN. And this is why I was telling you that it's a lot easier on the Nexus versus Catalyst. So you saw all that stuff you had to do for the Catalyst 9K side. On the Nexus side, it's that right there. 2 commands. Name the VLAN, VLAN 10, VN segment, here's the VNI. This is my layer 2 VNI, by the way. And then my layer 3 VNI is that. So that's all you got to do. Compare that to what I just showed you on Catalyst, and you see why I said what I said. All right. So now, once you have that, we have to look at the interfaces. So now we have to start mapping the interfaces here. Now I'm just going to show you VLAN 10 because I don't have anything else on here. So we look at VLAN 10. We have, the VRF member production servers. We have our SVI or the IP address, and then we have that fabric forwarding mode Anycast gateway, which is going to take this Anycast MAC address and map it to this SVI. So I actually want to show you the VRF too. Now the VRF stuff is a heck of a lot easier than Nexus. So let's look at it. So VRF context production server, we're going to give it the L3 VNI of 3000, which matches my 3000 VLAN. Then we're going to do route target auto. Just create the route distinguisher. Just create the route distinguisher. Don't really care. Then we're going to go to, IPv4, IPv4 unicast, and we're just going to auto create the route target. So you got route target auto for both, and you got route target auto EVPN. This is the same as the route targets you saw in the Catalyst, and then the stitching command. This EVPN is the stitching command, technically. All right. So now we got that under the VLAN. All right, we got everything mapped under the VLAN. And let me show you the other VLAN here, which is 3000. Now this is going to be my L3 VNI. So if I have to do some routing, I'm going to use this L3 VNI to get out there. The one thing you will see, at least in the data center side, is this MTU value. You should always make the MTU value at least 9216, because if you don't, VXLAN will technically give you some problems. It won't work because it won't be able to handle it without this MTU jumbo frame increase. The next thing here is we will do the VNI. So we go to the VNI here. I only have one. So you see how it's very similar but different. So we're going to use the loopback here. We're going to use the same host reachability protocol, BGP, right? So we're going to have BGP to host reachability. We're going to use BGP for that. Now, you saw member VNI 1000 multicast group, same whatever multicast group I want to have. And then your member VNI 3000 associate VRF, which is basically how I get out to route between stuff like that. After that, now we still haven't created the L2 VNI yet. All right, so we need to do that next. So the next thing we need to do is show run EVPN. I'll just do section VPN. Section EVPN. All right, so here's where we create the L2 VNI. So you have to do EVPN as the main menu. Then you say your VNI 1000, which is technically VLAN 10, but in VXLAN world, VNI is the construct that they understand. It's L2, so this is your L2. We're going to do another route distinguisher auto, so I'll just auto create the route distinguisher, and then we're going to do route target. I did route target both auto. When you do that, it separates them into two, but this is basically auto create the route target. And then the last thing you have to do is, from a BGP standpoint, is basically go into BGP, go into VRF, do address family IPv4, and is a command called redistribute direct route map, whatever the route map is. And that would be right here. So VRF production servers, address family, IPv4 unicast, redistribute direct, meaning whatever's directly connected, and then route map all routes, and that all route map is just basically saying, hey, just whatever it's blank, so that means every route. And then you're done. You are done. Now you saw how it's not a lot of commands on the data center side. On the catalyst side, is a lot of commands, but they're similar. So if you know how to do it on Nexus platform, it's not that hard to learn to do it on a Catalyst platform, especially if you know how to do like the EVPN instance stuff from the service provider network. They kind of took that, like I said, and added it to the Catalyst, which I wish they would have just took it from the Nexus side, because most people are going to deal with EVPN from a Nexus standpoint and not from a service provider standpoint. Most people, unless you're dealing with service providers and you're doing EVPN on that side, then you really don't have any familiarity with that configuration, which is, L2 EVPN instance, whatever, VLAN base. You don't have any familiarity with that. So Cisco, this is where, again, you should have took it from a platform that most people are going to see instead of a platform that most people are not going to see, which is doing it from the service provider end versus doing it from the Nexus end. Now, once you got all that done, if I do show BGP, L2 VPN EVPN, as you see, my VPN table is propagated like it's supposed to. We have some type 2s in there, which is your MAC to IP. We have some type 5 stuff in here, which should be coming from, if I really wanted to do this, because this is a lot of garbage, the route type 5. So we should see some route type 5 stuff in here. Let's see. Yeah, see, this is coming from shared services. This is coming from the campus fabric. See, 192, 168, 190. So type 5s is anything that's not going to be a type 2. Really, if it's not a /32, it's going to be probably a type 5, right? Because the /32 is the host route. The type 5 is usually the subnet route. So because 192, 168, 1.1/32 is technically the host route, you're going to see a type 2 for that. And within the fabric, by the way. And then outside the fabric, it's going to be, /24 that I'm sending. So you're going to see type 5 in there. So that populates all of that. And then from the border gateway standpoint, pretty much same configurations. The only difference here is what you're going to see from a BGP standpoint is so you're going to see this prod server. Instead of, I still have the direct route map. I still have that in there, but there's nothing directly connected. I just copied and pasted, so technically I don't really need this. But what you saw here is this going to the fusion routers. So that's these interfaces right here, 192.168, 3.0, or 63.0 and 62.0 go to the fusion routers. And that's what actually ended up populating those routes into the route table. See, you see that quad 0 coming from 62, which is coming from the fusion, and then you see all these other routes that are coming in, right? Here's my /32 at 1.1/32. Here's there should be a 24 up here. So here's what /24 up here. So this is all this stuff that's going to go into my production server VRF, and then it's going to be sent through the fabric in either a type 5 route for the most part, and then if it's within the fabric, obviously you're going to see your type 2 routes as well. And that, I already showed you that everything works and I can get to everywhere. But that is the story of two fabrics connecting via BGP all over the place via the Fusion router. So this was a fun lab to do. And I didn't do this because somebody asked me. Again, I did it because, one, I didn't really know how to do MP-BGP EVPN on Catalyst platform. So I decided to try it out and just see how far I can go with that using the concepts I already know. And then I was like, well, I know how to do it now, but it's not simulating, what a real network would look like with the WAN connectivity or data center connectivity and the internet block and stuff like that. So I decided to do that. And again, this was pretty fun to do. Um, there's a lot of, would I do this in the real world manually? Absolutely not. I'm just going to be honest with you. Like, I wouldn't do a mock of an SDA fabric. Go get Catalyst Center to do that, right? From the data center network, go get NDFC to do this. Unless now, if you're going to do all Cisco, NDFC, ACI. If you're going to do like Arista spines, but Cisco leafs, well then you got to do everything manually, right? So that's the only real situation where you have to build it manually, unless you just don't want to deal with the automation platforms. But this is why I always tell you, don't just study for the book, because there's nothing in the lab. You're never going to see this in the lab. Like when you go for your CCI, so they're never going to ask you to do something like this, in my opinion. Like now, Cisco might see this and say, "Oh, let's get people to try to do this manually." So you can blame me if they do that. But for the most part, you're not going to see somebody building all of this manually because there's a lot of moving parts. I didn't even show you the multicast piece. There's a multicast component here. There's IGP components in here. The multicast stuff is pretty simple. I'm using something called a Phantom RP. Basically, the RP technically doesn't exist, but the way I'm doing the subnetting, it's going to go to the longest match wins, so it goes to the node with the longest match, and that's what Phantom RP technically is. Um, but this is what you would see in the real world, though. Like, if you would see someone doing the SDA fabric, and then from you don't necessarily, now you look at Cisco stuff, they always usually have stuff coming off the border router, but you don't technically need to do that. I just moved it up from plugging my WAN connectivity and my internet connectivity to the border nodes. I just took that up and moved it up a layer to the fusion router where everything connects anyway. And then all I need to do from the border standpoint is just accept the routes that are coming from the fusion. I don't really have to do any manipulation at the border nodes to get up to the fusion. Just plug everything to the fusion and be done with it. Then I have my FortiGates because my lab can, like, these are not heavy nodes, so my FortiGates are in there. And that's pretty much it. Now, you're probably gonna have a lot of questions, so please don't, ask your comments and stuff like that. But definitely watch this video to understand some of the underlying concepts. Now, I do break down some of the individual stuff in other videos, like I believe I did EVPN on service provider. Watch that so you kind of understand what the EVPN instance stuff is. I've also showed you, fabrics, just data center fabrics, even multi-site design fabrics. I have videos of that as well. But if you got questions pertaining to this setup, go ahead and ask it, man. And I look at my comments all the time, so I'll reach back at you with an answer if I can answer it. If it takes me a little bit of research to give you the answer, just give me some time. So that's it. Multi-fabrics connected with a fusion router using BGP all over the place, even on the Fortinet routers for internet connectivity. For the junior people that see stuff like this, it does not take you that long. I don't want to discourage you. Don't look at this and be like, man, I'll never get there. You will get there in enough time, right? You will get to doing this manually in enough time as long as you don't quit, right? This is for inspiration to show you where you can get if you really love this game and you really want to put your study hat on and really get into these technologies. I hope you enjoyed this video. I know it's a long one. This is Don from Padlock Technologies. If you haven't subscribed already, please go ahead and hit that button, hit that like button, and share it to your network. I really appreciate it. Thank you, and have a nice day.